Imagine for a moment if our universe was flipped upside down. What if, instead of matter, antimatter ruled the cosmos? What would the stars look like? Would life even be possible? Today, we'll dive into this alternate reality, exploring what it might be like if antimatter dominated the universe. From anti-galaxies to anti-life forms, this story is full of mind-bending possibilities that could send your imagination soaring. Let's start with the building blocks of the universe, galaxies and stars. In an antimatter universe, galaxies would still form, but they'd be made of antimatter. These anti-galaxies would house anti-stars, which burn just as brightly as the stars we know today, but through a process called anti-nuclear fusion. Instead of hydrogen fusing into helium, it would be anti-hydrogen transforming into anti-helium. Picture the night sky, full of stars glowing with light, but each one is a mirror image of the matter-based stars we see. Gravity doesn't care if it's pulling matter or antimatter, so the structure of the universe would still be held together by the same invisible hand. Galaxies would spiral, stars would cluster, and the universe would look surprisingly familiar. But here's where it gets strange. In this antimatter cosmos, there wouldn't be any widespread explosions of matter and antimatter annihilation. The terrifying collisions we've all heard about. Normally, if antimatter meets matter, they both disappear in a flash of energy. Think of it like two puzzle pieces that don't just fit together, they obliterate each other. But in a universe dominated by antimatter, there wouldn't be much matter to collide with in the first place. This means these cosmic structures, galaxies, stars, and even planets would exist peacefully for billions of years, undisturbed by the catastrophic bursts of energy we might expect if antimatter and matter constantly mixed. Now, you might wonder, what about the chemistry? What does an antimatter atom look like? Here's where it gets fun. In this flipped universe, atoms wouldn't have protons and electrons. They'd have antiprotons and positrons, the opposite of what we know. Yet, the laws of chemistry would still hold. These anti-atoms would bond with each other to form anti-molecules, creating structures that resemble the matter-based molecules we rely on today. Imagine anti-water, made of anti-hydrogen and anti-oxygen, flowing across the surface of an anti-planet. You could have entire oceans of this anti-water, where the same rules of physics apply, except everything's made of antimatter. Let's dive deeper into this antimatter reality. Could life exist here? It's one of the most tantalizing questions, and the answer is maybe. Life, as we know it, is made of matter, DNA, proteins, cells. But in an antimatter universe, life could form from anti-biological molecules. Think about it. Anti-DNA storing genetic information, anti-proteins driving metabolism, and anti-cells replicating and evolving just like their matter-based cousins. If there were beings made of antimatter, they'd walk on anti-Earth, breathe anti-oxygen, and perhaps even gaze up at the same antimatter stars we just talked about. But how would we ever know if such anti-life exists? Well, spotting antimatter planets and stars wouldn't be too different from finding their matter counterparts. For example, just like regular stars burn through nuclear fusion, anti-stars would do the same, but with antiparticles. The light they emit would be indistinguishable from the light of our sun, but the story behind that light, that's where the magic lies. Just imagine telescopes pointing toward a distant galaxy, one that looks eerily familiar. But upon closer inspection, we realize it's composed entirely of antimatter, a ghostly mirror of our own universe. Now here's a mind-bending thought. What about antimatter black holes? Yes, they would exist too. When anti-stars collapse, they'd form antimatter black holes, pulling in anything, antimatter or matter, that ventures too close. These antimatter black holes would have the same powerful gravitational pull, the same event horizons, and the same mysterious singularities at their centers. In fact, from the outside, you wouldn't be able to tell the difference between a matter-based black hole and an antimatter one. But in this antimatter-dominated universe, entire galaxies might swirl around these antimatter black holes, shaping the cosmos in ways that parallel our own, but with that key twist of anti-reality. You might wonder, how did we end up in a universe dominated by matter instead of antimatter? The truth is, scientists still don't fully understand why matter won the cosmic battle during the Big Bang. If things had gone just a little differently, if the balance had tipped the other way, this antimatter universe could be our reality. And the most intriguing part, this antimatter universe would look strikingly similar to the one we live in. The Big Bang would still have sparked the creation of everything we see, but it would have done so with antimatter. The cosmic microwave background, the large-scale structure of the universe, even the way galaxies form. All of these would follow the same rules, only with antimatter taking the starring role. So, what about dark matter and dark energy, the great cosmic mysteries that puzzle scientists to this day? Well, it turns out that they likely wouldn't care whether the universe was filled with matter or antimatter. Dark matter interacts very weakly with regular matter, and antimatter too. It would still shape galaxies, provide the gravitational glue that holds them together, and keep the universe expanding. As for dark energy, the force driving the universe's expansion, it might behave just as it does now, pushing galaxies apart, whether they're made of matter or antimatter. In the end, an antimatter-dominated universe would be a strange, fascinating mirror of our own. The stars would shine, the planets would orbit, and, just maybe, life would find a way to flourish in this anti-reality.